Dear students, we continue the chapter Inverse Trigonometric Functions. Yesterday we recall the inverse trigonometric functions, dominant range of the sine inverse functions and cos inverse and etc. Then the properties of inverse trigonometric functions also. All these properties, keep it in your mind, then you solve all these problems. Yesterday we solved some problems like 1 mark questions which are asked in the examination. That I think you already know about the how can you using the properties of inverse trigonometric functions to solve the problems on inverse trigonometric functions. Today we shall solve some little more difficult because they are 2-step problems like 2 mark questions here. You already know, but I bifurcate all the type of problems which are on 2 mark questions in the question book. Inverse trigonometric functions. Two mark questions. First one question. Tan inverse 2/11 plus tan inverse 7/24 which is equal to tan inverse 1/4. This is the very important problem. In all question papers asked these questions many times. Now, we shall solve this problem by using the property like tan inverse x plus tan inverse y which is equal to tan inverse x plus y divided by 1 minus x into y. By using this property, you will solve this problem. LHS is equal to tan inverse 2/11 plus tan inverse 7/24 which is equal to tan inverse 2/11 plus 7/24 divided by 1 minus 2/11 into 7/24. This is the first step. We put the value of 2/11 and 7/24 replaced by x and y. Like x is 2/11, y is 7/24. We replace these in their place, x and y. Then this is the simplification of complex. It is this is simplification by adding these fractions and multiplying these fractions and subtract from 1. It's the simplification of fractions, complex fractions. It's already you know. First, you substitute these values is very important. Then it is the simplification method. By using some simplification method, here 2 by 11 plus 7 by 24, which is equal to tan inverse of, in the numerator, 11 and 24 are the denominator. Therefore, 11 into 24. Multiply this one. 11 is the first denominator, fraction denominator. 11 divided by 11 by 24, we get 24 into 2. It's the 48 plus 11 into 7 is equal to 77 divided by 11 into 24 minus 7 into 2, 14 divided by 11 into 24. This one is cancelled. Then we get tan inverse of 48 plus 77. 78 plus 7 is 15. 1. 4 plus 7 is 11 plus 1 is 125 divided by 11 into 24. 44. 11 into 22, 264 minus 40, which is equal to 250. 250. You once again write this also by tan inverse. Next step is 125 divided by 264 minus 40. We get 125 divided by 250, which is equal to tan inverse of 1 by 2. This is the answer, which is RHS. Simplification is very important here. The replacing or substituting these in the formula tan inverse x plus tan inverse y is very easy. First, you remember this formula. Tan inverse of x plus tan inverse y is equal to tan inverse of x plus y divided by 1 minus x into y. If it may minus, then it is equal to tan inverse of x minus y divided by 1 plus x1. Here it is replaced by minus, it is replaced by plus. Then in every question paper this type of question will ask. Then second question, 2 more problems are in your exercise. You solve yourself only. I do 1 or 2 problems that type only. Next problem. Write the function in simplest form. Write the function in simplest form. Which one is tan inverse of 1 divided by square root of x square minus 1, where mod x is greater than 1. Tan inverse of 1 divided by square root of x square minus 1, mod of x is greater than 1. Here we substitute. Here there is no proof here. LHS and RHS are not given here. But here we have to simplify the inverse function. This is simplified by substituting any trigonometric functions in place of x. Here x square minus 1. We put x equal to okay, you sec square or cosec square minus cosec inverse 1 or cosec theta. X equal to cosec theta. Then it's equal to, here we put, you ask me, if you take here sec theta also, because here if you take sec theta, it's sec square theta minus 1, which is square root, which becomes tan square theta. Sec is sec 1 plus tan square theta is equal to sec square theta. Therefore 1 minus sec square theta is equal to tan square theta. You already know, but here is tan theta is the answer. But here 1 by tan theta is cot theta. 1 by tan theta is becomes cot theta. But here we get tan theta. It's a very good answer. And then we can prove easily. Therefore 1 by cosec theta. Then we take x equal to cosec theta. Therefore theta is equal to cosec inverse x by theta is equal to cosec inverse x. Therefore tan inverse 1 by square root of cosec square theta minus 1, which is equal to tan inverse of 1 by cot theta. 1 by cot theta. Yeah. 1 by 1 cosec square theta minus 1 is equal to cot square theta. Therefore cot square theta is square root. I am taking here square root. Therefore which is equal to tan inverse of tan theta. 1 by cot theta. 1 by square root of cot square theta is equal to tan inverse of 1 by cot theta. Then tan inverse of tan theta reciprocal is cot theta reciprocal is tan theta. Therefore tan inverse can cancel. Therefore theta is equal to cosec inverse x. Yeah, we put x equal to cosec theta, then theta is equal to cosec inverse x. Is by inverse trigonometric function. Then tan inverse 1 by root of s cosec square x or square theta minus 1 is equal to tan inverse of 1 by square root of cot square theta by identity of trigonometric function. Then is equal to tan inverse of 1 by cot theta is equal to tan inverse of tan theta. Then it becomes theta. Theta is equal to cosec inverse x. It's the simplest form of this trigonometric function. Next, we shall go to the next problem. Here we forget about the trigonometric functions also. Trigonometric function is identities. Trigonometric identities also. Third problem, tan inverse of root of 1 minus cos x divided by 1 plus cos x. Here x is greater than 0 and less than 5. Write it in the simplest form. It also write it in the simplest form. There is not proof is given, or proof that LHS and RHS is not given. You should simplify the inverse trigonometric function. Here tan inverse, which is equal to here 1 minus cos x. You already know about the trigonometric functions like identity 1 minus cos x, which is equal to 2 sin square x by 2. Then 1 plus cos x, which is equal to 2 cos square x by 2. We substitute these identities in this function. 2 sin square x by 2 and 2 cos square x by 2. We get tan inverse of 2 cancel, sin square x by 2 cos square x divided by cos square x and 2 is equal to tan square x by 2. By taking the square root, we get tan inverse of tan x by 2. Then we write tan inverse and tan cancel, therefore it is equal to x by 2 is the answer. Putting these identities you should remember here. Another problem is write it in the simplest form. Fourth one, tan inverse of cos x minus sin x divided by cos x plus sin x. Here also x is greater than 0, x lies between 0 and 5. Here, to solve this problem, we divide numerator and denominator by cos x. Divide numerator and denominator by cos x. We get tan inverse of cos x divided by cos x minus sin x divided by cos x. Here also cos x divided by cos x plus sin x divided by cos x. We get tan inverse of cos x plus cancel here 1 minus sin x by cos x is tan x. Then here 1 plus sin x by cos x is equal to tan x. Here, which is equal to tan inverse of 5 by 4 tan of 5 by 4 minus x. How can you write 5 by 4 minus x? Because here we write it as tan inverse tan 5 by 4 minus tan x divided by 1 minus tan 5 by 4 into tan x. Tan 5 by 4 value is 1 and tan x minus tan x. Then here 1 plus tan 5 by 4 is 1 into tan. Therefore, we can write this one as tan 5 by 4 minus x by using tan x minus tan y divided by 1 plus tan x, tan x into tan y. Tan inverse of x minus y divided by 1 plus xy, which is equal to tan inverse of x minus tan inverse of y. Tan inverse of x into x minus tan inverse of y, which is equal to x minus y divided by 1 plus xy. Then using this one, we get tan inverse of tan pi by 4 minus x. Tan cancel. The answer is pi by 4 minus x is the answer. Sometimes this question will ask 3 marks also. You should learn for 3 marks or 2 marks. You should practice this problem. It's many times asked in the question paper. Next, yeah, fifth question. Tan inverse of x divided by square root of a square minus x square mod x is less than a. Here, x divided by square root of a square minus x square. Here, we take or we put some value trigonometric function in place of x. Which one is very useful here? Put x equal to a sin theta. A sin theta. Because here is a square is there. We put only sin theta. You can't take common a outside. Therefore, we put a sin theta. Therefore, it becomes a square sin square theta. We take an outside a square, which a becomes a. 1 minus sin square theta. We can get 1 minus sin square theta is equal to cos square theta. By taking square root, it's a cos theta. Then x equal to a sin theta, a gets cancelled, that is equal to x equal to sin theta divided by cos theta, it becomes a tan theta. You can use cos theta also, but we can't get the, if you put cos theta, a cos theta, you get here cot theta. Here you get cot theta, but you can't get cancel the tan inverse by cot. It's reciprocal, you get here. Therefore, we put x equal to a sin theta. Therefore, theta is equal to sin theta is equal to sin inverse of x by a. Sin inverse of x by a. Here, how can you write here? Because sin theta is equal to x by a. X by a. Then theta is equal to sin inverse x by a. Then we put tan inverse of x equal to a sin theta divided by square root of a square into a square sin square theta. Then a is taken outside, a sin theta divided by a square root of 1 minus sin square theta, which is equal to a sin theta, a cancel, sin theta divided by 1 minus sin square theta is cos square theta, taking square root, is equal to cos theta. Tan inverse of which is equal to tan inverse of tan theta, which is equal to theta. Theta is equal to sin inverse x by a is the simplest form of the given given inverse function. Then we shall go to the next problem. Like the same, but I will discuss. Here, tan inverse is equal to tan inverse of 3a square x minus x cube divided by a cube minus 3a x square. By glancing this problem, you know about 3a square x minus x cube divided by a cube minus 3a x square. It's the formula of tan 3 theta. Therefore, we put x equal to here a tan theta. Put x equal to a tan theta. A tan theta. You get here 3a square means 3a cube x means tan theta minus x cube is a cube tan cube theta divided by a cube minus 3a x square means a square. Therefore, it is also a cube tan square theta. Then we are taking a cube common, all are cancelled here. Taking outside, then only you cancel here. Therefore, 3 tan theta, you get 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta, which is equal to tan 3 theta. Tan 3 theta. Therefore, here tan inverse tan is cancelled. Tan inverse of tan 3 theta we get tan cancel 3 theta. 3 theta 3 is equal to tan inverse of x by 3 is the answer. Theta is equal to tan inverse x by 8. It's the same type of problem, but it is we take here is x equal to a tan theta. You practice yourself. I will give you PDF also. Then the next problem. Here also the same problem, same type of problem, but some root or square root are also sometimes given here. Prove that. Yeah. Next problem is prove that. That also 2-mark question. Here many problems, but in the question paper you face only 3 or 4 questions in this chapter. First you practice all the problems on this chapter. Prove that tan inverse x plus 1 by 2 cos inverse 1 minus x divided by 1 plus x, where x is belongs to 0, 1. Tan inverse root x, tan inverse root x plus 1 by 2 plus here is equal to 1 by 2 cos inverse 1 minus x divided by 1 plus x. Here it is the LHS, which is this one is RHS. We prove here by taking RHS to get it LHS. How? Therefore, I taking here RHS equal to 1 by 2 cos inverse of 1 minus x divided by 1 plus x. Here is equal to 1 by 2 cos inverse. Here we put x equal to tan theta. X equal to tan theta. You already know about the formula also. Identity of cos 2 theta is equal to 1 minus tan theta divided by 1 plus tan theta. You already know about this problem. Cos 2 theta in terms of tan theta, we get 1 minus tan theta divided by 1 plus tan theta. Here we get here by put x equal to tan theta. Then RH is equal to theta is equal to tan inverse of x by a. Always you write x equal to tan theta, theta in terms of ax also. 1 by 2 cos inverse 1 minus tan theta divided by 1 plus tan theta, which is equal to 1 by 2 cos inverse of cos 2 theta. Therefore, cos cancel. 1 by 2 into 1 by 2 into cos inverse of cos 2 theta is equal to 2 theta. Put theta cancel. Here x equal to root x, therefore x equal to 1 minus tan square theta. For this one, sorry, here root x tan theta is equal to root x. Here root x is given. Put root x is equal to tan theta, therefore it is equal to tan inverse of x by 2. Therefore 1 by 2 tan cos inverse 1 minus tan square theta divided by 1 plus tan square theta. Therefore 1 minus cos inverse of cos theta, we get 1 by 2 into 2 theta, which is equal to theta is equal to tan inverse of root x because here a is not given here. Root x equal to tan theta, therefore theta is equal to tan inverse of x. I take here, taken here RHS side 1 by 2 cos inverse of 1 minus x divided by 1 plus x. Cos 2 theta is equal to 1 minus tan square theta divided by 1 plus tan square theta. Therefore, put root x equal to tan theta. Then only it becomes x. Square becomes x. Therefore, here 1 minus tan square theta divided by 1 plus tan theta, which is cos 2 theta. Cos gets cancelled. Then 2 also cancelled. Theta remaining. Theta is equal to tan inverse of root x. Then next problem, it's very easy problem, but you have to put some identities. Root of 1 plus sin x plus show that plus root of 1 minus sin x divided by root of 1 plus sin x minus root of 1 minus sin x is equal to x by 2, where x is belongs to 0, 5 and 4.
equal to pi by 4. Here it's cos part, therefore the slice makes the equal to pi by 4 given. Cot inverse LHS is equal to cot inverse of here I write 1 plus sin x like